Here is a sequence, converge or diverge. Let's find out. I have the top, I have ln n to the third power. The bottom, I have 2n. So based on the power rule of ln, I can bring that 3 to the front. So 3 ln n. And then divided by 2n. And then I will take the limit as n approaches to infinity. I have 3 ln n divided by 2n. This one, if you just plug in, you will see infinity over infinity. That one, in this situation, the limit when you have infinity over infinity or 0 over 0, they are indeterminate form. You can use the L'Hopital's rule. L'Hopital's rule. L'Hopital's rule means you will need to take the numerator and take the derivative of the numerator, and then you take the derivative of the denominator. So we will join h. H means I will use L'Hopital's rule, limit as n approaches to infinity. The derivative of 2n is equals to 2. Derivative of 2n is equals to 2. The derivative of 3 is 3. The derivative of ln n is 1 over n. And then this is equals to, notice that before I move on to the next step, I need to remind you that this is not a quotient rule. This is not a quotient rule. According to L'Hopital's rule, I need to take the derivative of the numerator, put the result in the numerator, and then I take the derivative of the denominator, put the result in the denominator. And then equals, so no h means I am not using L'Hopital. I am just trying to rearrange the terms. I have 3 over 2 to the n. Can I plug in? Yeah, we can. 3 divided by 2 times infinity is infinity. 3 divided by infinity is nearly 0. So since the limit is equals to a real number, so we say the sequence converges to 0. All right. Okay, I do have another sequence that use L'Hopital's rule, but before I get into that, I want to do one that has a factorial. So this one is an equals to n plus 2 infinity divided by, no, not infinity, factorial, divided by n factorial. I need to remind you that the n factorial is equals to n times n minus 1 times n minus 2 times n minus 3, and then you keep on multiplying until you reach to 3, 2, 1. Don't multiply 0, because if you multiply 0, the whole thing is equals to 0. So let's say 5 factorial, that is 5 times 4 times 3 times 2 times 1. Don't multiply 0. And then a special case is that 0 factorial is equals to 1. That is a special case. Okay, this one I will take limit as n approaches to infinity, n plus 2 factorial divided by n factorial. So that is equals to, we don't need to do L'Hopital's rule right now because there is a simplification that we can do after expanding the n plus 2 factorial. So n plus 2, 2 lose 1, and then that is plus 1, 1 lose 1, and then you have n, and then you can keep on multiplying, n minus 1, n minus 2, n minus 3. I decide to put a stop right there because the denominator has a n factorial. That means I can go ahead and then cross out the n factorial, and then what do I have left? I have this left. So once you plug in infinity, then you will have infinity. This one you don't need to multiply. This one you can multiply. Then you will have in n square plus 3n plus 3, and plus 3 plus 2 plus 2. And then when n approaches to infinity, then you will have infinity plus 2, that is equals to infinity. So this one starting from A1, and then you can go to A2, and then A3, and then A4, all the way to AN, and then you keep on going. So as you look all the way to the right, so these terms are nearly infinity. Those terms are really big. So therefore, this sequence diverges. All right. Okay, moving on to another problem. how about this? We already introduced a L'Hopital's rule and then we introduced a factorial. How about let's do a squeeze theorem? You haven't done that for a while. Okay, squeeze theorem. Let me give you this problem. An equals to cosine 2n divided by 3 raised to the n power. I will do a limit as n approaches to infinity, cosine 2n divided by 3 to the nth power. When you have a n goes to infinity and then the function has a cosine or sine, usually we need to do a squeeze theorem, and then I need to also remind you that cosine infinity, this one is undefined. You cannot use L'Hopital's rule. So this one is not infinity over infinity. You cannot use L'Hopital's rule. I need to start from cosine 2n. And then just like cosine 2x, you have a 2 in front of the independent variable that affects the period only. That doesn't affect the range. So this is between -1 and 1. Why between -1 and 1? If you graph sine or you sketch the graph of cosine, you can see the graph is bouncing between -1 and 1. This is also the range of cosine. The range of cosine. And then do you see that n approaches to infinity? So n approaches to infinity, that means for the cosine, we will, this one n approaches to infinity. N approaches to infinity, the n we don't start from negative. We always start from 0 and 1. N we always start from 0 and 1. So when n is from 0 and 1, so that means you will have a cosine of a positive quantity. You will have a cosine of positive quantity. So what I am thinking is I will just take the absolute value. I will just take the absolute value. So you sketch the graph of cosine, you take the absolute value of that, but so the absolute value right there, so this one, the absolute value of -1 is not the absolute value of -1 equals to 0. This one is you sketch the graph of sine and cosine, you take the absolute value of that, so you have to cut the pieces that the graph is below the x-axis, and then you have to flip that to the top where the graph is now between 0 and 1. So it was between 0 and 1, right? This is a sine. So you have to actually cut this and then flip that over. So that is the graph of absolute value of sine. The same concept applies to cosine. So now the range is between 0 and 1. It's no longer between -1 and 1. So I am not saying that the absolute value of -1 is equals to 0. It's because we have to flip the curve to upside down to a place where y is positive. So that's why this is between 0 and 1. It's between 0 and 1. And then you can divide each side by 3n. And then what about when n approaches to infinity? So when n approaches to infinity, so this one I can say when n approaches to infinity, 0 divided by a very large quantity, 1 divided by a very large quantity, this is a 0. And then less than or equal to, this is 1 divided by a large quantity, so that is 1 over infinity equals to 0. What is sandwiched between 0 and 0? So that tells me that this must be 0. That also tells me limit as n approaches to infinity, cosine 2n divided by 3 to the nth power, that is nearly a 0. So that means the sequence converges by the squeeze theorem. All right, so that would be another problem. Okay, let's do the last one. The last one, I would like to do another L'Hopital's rule. Okay, I use purple, gray, green. Let's use pink. Okay, last one. This one, let's do a limit. An. N multiply sine 1 over n. And then this one, when you have n approaches to infinity, you will have infinity and then times sine 1 over infinity. And then you will have an infinity divided by sine of 0. Infinity times 0. We will have to use a L'Hopital's rule right here. To use the L'Hopital's rule, so one of the reason I hold on. Zero, this is infinity times 0. This is one of the indeterminate form. We cannot use L'Hopital's rule right here. No, that is impossible. So that means we will need to rewrite the sequence a little bit. So an, how about this? I keep the sine in the numerator, and then I move the cosine to the denominator, 1 over n. How's that? So this one will be sine 0, and then this will be 1 over infinity. So we have a 0 over 0, and then we can use L'Hopital. This one we can use L'Hopital. Okay, let's do a limit as n approaches to infinity. Sine 1 over n divided by 1 over n. Using L'Hopital, 1 over n, n to the negative 1. Take the derivative of that. We have negative 1 over n squared. Bring the negative 1 down. Negative 1 minus 1 is negative 2. And then the top, the derivative of sine is equals to cosine. So cosine 1 over n. And then chain rule, the derivative of 1 over n is negative 1 over n squared. And then you can see that these two pieces will be cancelled. These two pieces will be cancelled. That leaves you a cosine right there. So you have a cosine 1 over infinity, and that is cosine of 0. Cosine of 0 is equals to 1, so that is equals to a real number that is not infinity, that is not undefined. So since the limit exists equals to a real number, then we say the sequence converges. Alright, so these are the 4 examples that I believe is a good representation for this kind of problem in your homework. So if you think that I picked a good problem and then give you a good discussion, give this video a like, subscribe to my channel for more contents like that, and I will meet you all in the next lesson.